Hi, my name's Harry Mannering. I'm from Group 2. This is Charlie's problem. I'm the speaker on it. It's homework 3, number 2.4. Conceptual question, pretty much asking what the difference between the limit of x going to infinity and limits at a point are. So limits of x moving to infinity and x to a point are both functionally similar. We use them for different purposes though. While both limits are used to find values that don't technically exist at arbitrary positions, limits of x to infinity are used to find values that a function as a whole will approach as larger and larger values of x are plugged in. While limits at a point are used to find specific outputs of a function that are almost within the domain of the function, but are otherwise restricted from it. So take, for example, we have the limit of 1 over x as x goes to infinity. We've seen this before, and we can graph this and see intuitively where it's going. So intuitively, we know that this is going to 0. It is going to be smaller and smaller and smaller, and the limit of this function will be attempting to approach 0. And we can prove this algebraically with 10 to the minus k, plugging it in, eventually giving us, or not plugging in, determining the accuracy, 10 to the minus k. And we can prove algebraically that this moves to 0. But the core of this question is, what are we trying to find here, setting this equal to infinity? We're not trying to find a certain point like z here, and finding the limit specifically here. Sorry for using z, it's only temporary. We're trying to find the goal or the limit as x gets larger and larger and larger, and what goal the function as a whole will approach, which in the case of 1 over x would be 0. Now, at a point though, are we looking for the long-term behavior? No. We're looking for the behavior of the function around that point, or the limit at that certain point of the function. Take, for example, the limit as x moves to 3 of x squared minus x minus 6 over x minus 3. And what we're looking for from this problem is what is the limit of this function as we move to 3 specifically, not to infinity. We're not looking for the long term here. We're looking for this point, what is around this point. In this case, we simply solve it out whereby factoring the polynomial on top, getting x minus 3 times x plus 2 over x minus 3. X moves to 3. Factor those out and go to the limit as x moves to 3 of x plus 2. Now, at this point, we can tell this is a continuous function, so we can then just directly plug in 3 into x plus 2 to get 5. And that would be the limit that you have at that point. So it's all the difference between these two, the limits moving to a point and limits moving to infinity, is the long term for extremely large values of x versus the around a specific point. Thank you.